I know if I say, hey, let's get it done in 4 weeks, then it's going to be a disaster because you probably won't start working until the fourth week. So I divided up everything to all these baby steps and give you credits for every step. Let's take a look. So today's September the 30th, and we'll look at the schedule and I'll show you the materials I have so you know what are available for you guys so you can have a plan for that. So you can see on the schedule we are going to focus on this balancing card design for the like future 4 weeks or more. And what I'm thinking is you need a frame first. So complete the card frame can be a 3D printing frame or can be something like mine, like this. Either way, but I prefer a 3D printing. If you guys already got started, use a 3D printing, just go ahead. Because this one is hardly can be a product. But I think Zane, did you say you like cutting things? Like yeah, something like this. So I'll show you what is that material I have. Let me bring it over. If you'd rather cut it, I bought pretty much 10 of these boards. These are the same material like this one. Oh, okay. I just cut myself in the summer. So we have a lot of these ones, the boards you can cut. And the slats, they're too long. You need a special cutter to cut it. Huh? What size is the thread? Not the size you would have. It's different. I can send you the link of this. I forgot. I remember. These ones available. Also the wheels or the tires. So the tires are really annoying. So no matter you are trying to cut or 3D print in the frame, you do need to 3D print adapter between the stepper motor and the wheel for the tire. Let me give you some of the tires so you know how do we want to do that. It need a little bit work on that. We have tires. Did I give you the tires already? Yeah. What is? You're just kind of the people on the phone, but yeah. Those look like standard threads. Yeah. He's like standard what? Just standard thread. Well, no, I mean it's like an M5. Oh. The one that's in by email. When did you have the link? Or the next part for this, right? So maybe 6 minutes.
It's like a. Rubber bands.
So let me tell you my idea. You see that on the other side, we have so just put a nut, right? In here. And you need a thread.
You could just take measurements of this and then just print that basically me into the nut and then just have an adapter to the. Yeah, measure the wheel and then measure this and then just extrude it.
Yeah, not. And you probably need to design a patcher, right? So you insert the rod into there. And the other side of that patcher should be a straight nothing. It's a cylindrical shape or something. So it goes through here. Oh, wait. So definitely this is outside. Okay. So the thatcher from the stepper motor, then you want to 3D print hexagon to put in here. But the other side should be something you can screw in and immobilize everything on the outside. What that should be.
You could just put threads on the inside of the 3D print. You just have like a screw hole basically and then threads on the back.
Yeah.
That would be kind of hard to do in SolidWorks. But. Oh yeah, just drill into it. That's happening screw and that'll do it.
Yeah. It's hard to remove it later.
I haven't seen that problem. But then again, usually, like, a lot of times I just glued it at that point.
Yeah, I glued everything on that one, but I didn't see this one right here. This is for temporary.
It won't split it, will it? Like if you get too big a screw, it could split it. Use a smaller screw. That'll do it. And that'll be that.
Yeah, you don't need a certain hole. The first time you use a fuel, right? You can force it in and raise the correct side inside. So that's fine. Just need on the hexagon to put it here. On the other side, you just force it.
You can pre-drill it too and get your screws a little big. So you don't split the whole thing.
Yeah, but that's the side. Yeah, so you put the shape. So, yeah, on the other side, you put your so you got that, so the other side of the battery should be in here.
Oh, I see. That all we got for today, or?
Let me see. No, schedule. I haven't finished the schedule.
Oh, yeah.
Yeah. So that's next Monday, right? October the 5th. You need a solution for this. That's the deadline. If you don't have it, you lose a point, 20 points. So next Monday, October the 5th, for the frame and 3D printing. That's a lot of work, not just this, right? And also the frame and everything here. So that's the homework for this week. And then the week after that, still Monday, complete the tasks in part 1 and part 2. So which means you need so the Monday after next Monday, you need something like this, and it should stand on table surface in 2 weeks. It's just needed to make all the hardware connection, and the code is already provided on the website. Before you improve it, just use it. 2 weeks should be reasonable, right? Just upload the code and make it work. You just need to build the car like this and make it work. 2 weeks. And then you have 1 week plus 5 days, about 12 days to complete the wireless control. So literally, today is the last day for this month, right? And you have 23 days to have the car that can be controlled by a wireless controller get done on the breadboard. And then you have how many days? Let's take a look. A week to convert everything to a PCB. So on the 30th of October, I will start uploading your PCB design file to PCBWay and pay that for you. And you need to present the result on this day, Wednesday. So here's the thing. This is a 300 level class. According to ABAT, we need to cover ASICs. We need to let you guys present. We need you guys to form teams. So where can I find that information? Syllabus, right? And we want the C program to be ABAT accredited. You don't. This is something like required for everywhere. We couldn't do that until we have the first graduate. So I'm actually relying on you guys. After graduate, I can submit the application for that. So if you look at all these outcomes for the course, so these 7 items are for any engineering programs, computer engineering, mechanical, electrical, civil, everything. So the first one, the first level, solve equations. I give you a homework assignment, solve it, turn it back to me, done, homework, right? And the second level is design. So the key word is design. So 1 and 2 are pretty simple. You probably have done this for many times in like circuit 1, circuit 2, right? All these courses. And 3, communicate. Presentation, writing a report, especially presentation. So if we want to, we have to include this one into this course. So you have to present, form teams, okay? And next, ASICs. So I'm going to give you a assignment about ASICs and let you present it later. It's going to be pretty simple. I just give you like 20, 30 pages with all these engineering ASICs examples, and you just read it and present it, see what are your thoughts and things like that. And then team, collaborative. So number 5 is team. That's why I'll ask you guys to form teams, right? And lab, no problem. We have done a lot of labs. These are everything is a lab, right? And the last one, new knowledge. Sounds great. So what that means is I will assign you some tasks without giving you the solution. So you are acquiring new knowledges from anywhere, right? Whatever. So you are learning something new. So this is actually every design course will include this part. Doesn't like the junior design class. I have every single experiment have a tutorial on the website. So you need to get something done without a thorough instruction with you. So you are acquiring new knowledges. If you go to graduate school, you'll feel that your advisor, even your advisor is super powerful, like the #1 guy in the field, super knowledgeable, probably your professor will help pretty much zero for a project everywhere. Um, that's great already, because sometimes they are contributing negatively for for your projects, because you want to do this, your professor say no, you have to follow this way, and you definitely know that's wrong, but you still have to. Sometimes they are doing something negative for you. But they will never, normally, they will never step into your project and ask you to, because like James has been working on the EPA project. I mean, you have been going so deep into that project. I definitely don't even know what they are doing there right now. Right? I don't even have time to look at the code. Similar situation. Whenever you are in graduate school, you have to work in that situation for 4 years. Think about that. You have to work independently. Whenever they are hiring students, um, one of the key criteria is working independently. So you couldn't expect your professor to do everything for you. Then it's not you are pursuing the degree. Your professor is doing that for you. So you do need to know how to acquire new knowledges and how to search online and combine other people's stuff to yours and make it work. It's the same situation when you get a job in the industry. Right? That's why they hire you. If they know how to do that, they won't hire you. They need you to help them. Right? All right, so we definitely, are doing all of the 7 entries in the ABAT criteria. I think this is reasonable as long unless you are not able to get it done by this deadline. We can probably extend it a little bit, but no more than a week. So pretty much a month from now, you should get everything done, including the PCB, and everything should be functioning. Any questions? No? All right. That's it for today.